Today's lesson is section 1.4, Building Functions from Functions, part 1. First thing that we're going to talk about is combining functions algebraically. So if we have two separate functions, we can add these functions together, subtract them, multiply them, and also divide them. The rules are listed here. We will be doing examples on the next slide of all these. So for this example, I have f of x equals x squared plus 1, g of x equals x plus 5. And we are going to find f plus g, f minus g, f times g, and f divided by g. So we'll look at f plus g first. It's always safe to put parentheses around each function when you add, subtract, multiply, or divide. In this case, I really don't need the parentheses because when you distribute, you're distributing a 1 into both of them. So I really don't need them. So what I'm going to do is combine my like terms. When I combine my like terms, I get x squared plus x plus 6. Next, when we subtract f minus g, here again I am using parentheses. This time it is important that I do have parentheses because of the minus. I will be distributing the minus to the x and the minus to the 5. So my next step looks like this: x squared plus 1 minus x minus 5. Again, when I combine like terms, I get the answer x squared minus x minus 4. Again, I'll repeat, the parentheses are very important, especially in the second set. When we multiply f times g, this is just like FOIL, or distributive property. We will take x squared times x squared times 5. 1 times x, 1 times 5. When I do this, I get x to the third plus 5x squared plus x plus 5. Notice in this situation, there are no terms that can be combined together. The last one is probably the easiest because a lot of times there is no simplification that you can do. Just like this, x squared plus 1 divided by x plus 5. There is no simplification I can do. Do not think that you can take an x out and cancel out. Because of the addition, this is not possible. The last thing that we are going to talk about today, which is going to be the toughest thing in your homework, is called composition of functions. This is a function within a function. How I read this is f of g of x. The second notation makes a little bit more sense because g of x is inside f. So how you remember is the second function goes inside the first function. So if this was wrote the other way, g of f, f would go inside g. But in this case, since it's f of g, g goes inside of f. I have both examples here below. So the first one here, before I uncover it, I am going to take g and I'm going to plug that in for x on f. And what I did, if I circle this here, I took this function right here and plugged it in for x. That's what I did. And since it was just x here, it's just 2x squared plus 2. There's no other simplification I can do. Now, if I look at the second one, I'm going to take f and plug it in here. So I'm going to take this whole function right here and plug it in for x. See what happens here. I have to create the parentheses, x plus 2. That is squared, and I multiply it times 2. Now when I simplify this, this is going to be a little bit more complicated. X plus 2 times x plus 2, if I extend that out, I get x squared plus 4x plus 4. I have the 2 outside, and what I'm going to do is distribute the 2 in. Again, how I got that is I separated x plus 2 times x plus 2. When I FOIL that, that's how I got x squared plus 4x plus 4. Again, when I distribute the 2 in, my final answer is 2x squared plus 8x plus 8. So as you look at these two, they're obviously not the same answer. So f of g is different than g of f. And in this case, g of f was a little bit more work. We will do a couple more examples of this in the next slides. The next thing I want to talk about is actually plugging in a value for x. So what we're doing in this example right here, we're finding f of g of 4. It tells me I'm going to plug 4 into g first. I'm going to get an answer. Then I'm going to plug that answer into f. That's how this is going to work. So the first step is I'm going to take 4 and plug it into g. So if I take 4 and plug it into g, 4 plus 3 is 7. So now I have this. Now I'm going to take 7 and plug it into x squared. So 7 squared, 49. 49 minus 4 is 45, and we get an answer. If it was x, we would just be plugging in the function, but since it is a number, we can take the number, plug it into the first function, get an answer, take that answer, plug it into the second function, and get our final answer of 44. If you did it backwards, you would not get the same answer. What I have here is a couple more practice problems of doing f of g and g of f. So right here, f of x is x squared minus 2. G of x is the square root of x plus 1. So the first one, if I take g and plug it into f, I'm going to take this function right here and plug it into x. You can see what it looks like. So I have parentheses. I always put parentheses around the function that you're plugging in. I'm taking the square root of x plus 1. Then I'm going to square that minus 2. Again, I took g and plugged it in for x. Notice the simplification here. The square root and squaring cancel each other out. So I would be left with x plus 1 minus 2. Simplifying that, I just get x minus 1. Now if we did the opposite, now I'm going to take f and plug it into g. So I'm going to take this whole function here and plug it into x. Again, I put parentheses around x squared minus 2 because that's my new x, and plug it into g. So it's the square root of parentheses x squared minus 2 parentheses plus 1. Again, in this case, I really don't need the parentheses, so I'm going to combine my like terms, which are negative 2 and 1, and I'm just left with the square root of x squared minus 1. Again, I cannot simplify x squared because of the minus 1. My answer is as simple as it can get. Again, sometimes one problem is easier than the other, and in my opinion, the top one is a little bit more complicated than the bottom. This one had less simplification. Your homework that we're going to work on in class tomorrow, again, is just going to be adding, subtracting, multiplying, dividing functions. and then we're going to do the composition of functions, the f of g and the g of x. Your homework is page 127, 2 through 20 even. We will do part 2 the next day.